Okay, so for this problem, we want to find the derivative of this function h of x, which is x squared times e to the x times tangent of x. And this is a product rule, but in fact, it's actually what I refer to as a triple product rule because you have three functions being multiplied, which cannot be consolidated down to just a simpler expression. So the idea to make this simple as possible is to actually bundle together the first two functions and think of those as my f of x, and then leave the third function as my g of x. And then when I find my derivative, I'm going to use some prime notation. Okay, so using primes, we're going to have our first function, which is x squared e to the x, and it's going to be the derivative of that coming up in the next stage of the problem, times the tangent of x plus the first function, which is x squared e to the x, times the derivative of the second function, which is going to be the secant squared of x. And now what we can do is expand that derivative of the first using our product rule again. So using our product rule, derivative of x squared is 2x times the second plus the first times the derivative of the second, which is e to the x again. That's still times the tangent of x. And that's still going to be plus our x squared e to the x times the secant squared of x. And we can simplify this down a little bit. You will notice that all three terms are going to have an e to the x, and they also have one power of x. So you can factor this as h prime of x is equal to x times e to the x, and then what's left over is going to be our, let's see here, we're going to have a 2 okay, so again, that's going to be x times e to the x times 2 plus just plain x, and that's still times the tangent of x. And then back here, we can take out an x e to the x. It means me about the x times the secant squared of x. So if I factor out that common x e to the x, I am left with the sum 2 plus x times the tangent of x plus x times the secant squared of x. And that's about as far as we can go with this problem, unless we were to use some sort of trig identities to simplify down the tangent and secant squared, but there's really no gain in doing that for this problem. So that right there is the derivative of our triple product. And again, we could have left it just at this stage right here and been totally fine for our derivative. There's really nothing was much gained from factoring that down.